Good evening, friends, AIA Brooklyn et al. We're going to call the meeting to order. I am James Coster, Executive Director of AIA Brooklyn. I want to welcome you all tonight. Say thank you to our hosts, FX Collaborative, for providing this remarkable space to us. And please sign in if you didn't, especially if you want AIA credit for tonight's presentation, which will be very interesting and informative. And I'm going to present Sarah Drake, Principal of Sarah Gordon Drake Architects and President of AI Brooklyn, for a few remarks and some chapter business.
Thank you, James, and thank you for being here. I have a first question. How many people here are new members? Welcome, good to see you. I'm very glad you're here. We do this not every month. I think we skip at one, maybe we skip one in August in the summer, but otherwise you should see us at our meeting. I wanted to first say I'm officially now calling the meeting to order, and here is our mission. AIA Brooklyn is dedicated to the advancement of the architectural profession through education, outreach, and mutual support. And I can see that we have a quorum. I'm going to first mention some chapter and committee events that are coming up. You can find them on our website. You can also find them in your emails that are sent to chapter members. If you're not on our mailing list and would like to be, let us know by writing to info@aiabrooklyn.org. Next Wednesday, October 23rd, we have an event at the Macintosh, is it their showroom, Joe? Yeah, it's at their showroom. Joe Harris from Crescendo Designs is organized this for us. Thank you, Joe. And it's called The Role of the Integrator in 2024, House of Sound. So this will be an evening from 6:30 to 9 with one learning unit to learn more about the, you will learn more at the Macintosh systems. 3 rooms of audio demos by Macintosh and Crescendo teams showing you how to make an exciting, they will have an exciting theater demo. Tomorrow, by the way, is our Brooklyn Queens golf tournament. If you really have nothing else to do, you couldn't think of it. Exactly. Sign up for a day of golf, or just the evening, dinner and cocktails. You'll see that again on our website. Emerging Professionals has our Brooklyn, it's called BCAP. Chitra is one of our co-chairs for that committee, and we're having what we call an Ask Me Anything event at here, FX Collaborative, on Thursday, November 14th, at 6:30. Lasts about an hour and a half. And what is the subject? Do you have that? Look on our website. Coming up, the program will be announced. But we did this
parallel pathways.
Parallel pathways, and you will be able to ask and interact with 3 panelists, and it will go like that. It's a great experience. Our BCAP committee has many other events that are posted on our website. There are CEU webinars on the menu coming up on November 7th, Luminous Surfaces for Architects, laser scanning, November 21st. Speaking of laser scanning, there's a tri-state fusion conference done by AIA New York, Pennsylvania, and New Jersey. And in Hershey, it lasts several days, starting on November 18th to the 20th. And I'm going to be one of the speakers working with existing conditions to talk about laser scanning for small businesses, pros and cons of doing it yourself versus hiring a company to do it for you. I also wanted to say that last week, some of us here in the room, Chelsea, one of our directors, Chelsea Davis, and Gemma, who's a co-chair of our newly formed Women in Architecture Committee, we visited Chicago last week for AIA's Women's Leadership Summit, and it was a wonderful experience. We'll tell you more about it coming up on, hopefully on our Brooklyn Pylon blog, brooklynpylon.org. You'll see other articles there as well. So now I'm going to introduce you to Howard Schlesinger, AIA. He is he's from VRF Solutions, which is a, where are you, Howard? Oh, come on up. Mechanical. Oh, wait, sorry, I've forgotten a whole section of this announcement. The other thing we're here to talk about, I'm going to introduce you to our Vice President, Marshall Schuster, who's the chair of our nominating committee, and we're going to talk about the next role that we have to do is to announce our nominating committee to the members and find people to join our board of directors.
Thanks, Sarah. So yeah, we have a few open positions that we're going to be searching to fill. A couple of those positions are on the executive committee, and then we have a few director positions open. So we have a search committee, and that search committee will be chaired by myself. Tom Lewis has agreed to be on the committee, Michael Licht, Jordan Parnas, and Michelle Prockwell. And so we're already in discussion with several of the members of the board to fill in these positions. We'll have a few open directors positions as well. And so if anybody is interested in volunteering more, please reach out to me. You can email me directly at vp@aiabrooklyn.org, or any of those members of the search committee can help as well. Thank you.
Have I been muted? No. Okay, so now I'm going to introduce our headliner, Howard Schlesinger. Howard is an architect, but he is also vice president of VRF Solutions, which is a design build mechanical contractor specializing in these new electric high efficiency systems that are, kind of leading the way in the electrification of New York and decarbonizing the city. And he's also a City College alum. So I know there's several of you in the room, so you can step up and meet a fellow alum after. Howard.
That's right. Thank you. Look, the only thing that I would add to it, only because it's relevant to why I'm saying the things I'm saying, is that I was an architect at a firm for 10 years. I take it on partners, I had sold it, and I jumped out the window and became a developer. So my past 20 years have been as a real estate developer, rescuing underutilized properties. And I sold my last portfolio piece about 2 years ago and went into the energy space. So that's why I'm here, because 3 years ago, I got the idea that energy was really coming up the curve, and it was a real opportunity to enhance what's happening there. And with my background as an architect, as a developer, and building businesses, I saw this as a really great opportunity. And coming from architecture, it's a great starting point to work with engineers and other people, because we as architects see things holistically. The rest of the players mostly see what they solve for. So I think we have a very unique position as architects to capture what's happening right now as a transformation of our built environment. So there are a couple of things that came together that really motivated me to see that this is the time to do this. One, as we all know, is legislation. The other is a social consciousness that came out of COVID and clean air and that kind of mission to make sure that our buildings are safe and healthy. And the third is the cost of buildings in terms of what energy is costing these days. Systems that are 100 years old now are failing, and they need to be replaced. And what they can be replaced with is more efficient systems. So that became the Carbon Mobilization Act. And that's what we're going to talk about. That's the theme of this, is the Carbon Mobilization Act. But I'm going to walk you through all the elements that I just mentioned. And I have this really cool thing. So that's me. And I think this went out as a learning objective, so I'm not going to read any of these. There's a lot of words in some of these. I'm just going to give you a quick what theme of each one of these slides is. But, you know, the local laws, we all know these are local laws out there. Understanding of heat pumps and understanding of strategies when you specify them, how they get coordinated into our designs as architects. And then also identifying complementary technologies. Oh, is that better? Can people hear me though? Is that cool? Or you like this better? Really?
If
Okay,
you
cool.
turn to the screen, we can't hear you. So now we can.
Okay. So anyway, so there's all these other technologies that are showing up, which are really important. So the whole key to this process is really to look through the lens of a holistic view. It's the systems, it's the envelope, it's all those things. And then we'll talk about the resources, because coming from my development head, the capital stack is a very important part of this conversation, and what the return on investment is for all of this. So you'll see 7 things come up. I have a rule of 7 when I do this kind of stuff. And so whatever it is, I try to make it into 7 things. It's a good way to remember them, and you can remember which one you want to ask about. So they're all numbered. But this is our goal. Healthy, safe buildings, holistic approach, maximize the system integration, which is using all technologies, not just one. Central ventilation systems, ventilation of the HVAC, the B, is really critical to everything. You might want to start there as one of the keys, making these things work. And then how prop tech works. So you take all that together and you want to really record and then keep monitoring and having good feedback, so you can always keep tweaking the systems that you build. And then what you wind up with is lower operating costs, increased value, and for owners and developers, an opportunity to brand their product. So legislation, that was the first thing that came up, and it was a whirlwind from the CMA onto Local Law 97, which now became common language. When it first came out, nobody knew what it meant. And some of you in the room know who that guy is. But he had all these great little sayings, and that was the one that I think really applies here. We really didn't know what's coming. This came, and we related it to our restaurants, and we wouldn't walk into a restaurant that was a C or a D. Well, as time goes on, if you see one of these letters, C, D, or F, on a building, you're not going to buy the condo. You're not going to rent the apartment. That's going to be a deterrent as it becomes more mainstream as to what these represent. And then Local Law 97. So in Local Law 97, and at this stage of the game, since it came out in 19 and it's now implemented in 24, I think we're all familiar with most of this. Anybody wants to go back on any of this stuff, I'm happy to do that. But the key thing here is that I didn't turn off my phone. Anyway, so the main thing here is that it started in 24, but reporting starts in May of 25. So May 1st of 25, all the record keeping that's supposed to be happening now starts to get reported. And those buildings that are unfortunately in that zone of actually paying for stuff, it kicks in literally now. That's the history. That's May 1st, 2025. First compliance reports due. So that's what we're all looking at. So all of your clients need to be aware of this, because if they're not paying attention to it, it's going to come back and bite them. So this is what happens when you get a D. And right now the D is, people don't know exactly what it means. They think they have a restaurant in there somewhere. But that's going to go away. And this is going to be mainstreamed in terms of what happens with the brand, what happens with indoor air quality. This is all about energy efficiency. It's not the Carbon Reduction Act, which is Local Law 97. This rating is just for energy efficiency. Local Law 88, which came out a long time ago, was just to start recording all this stuff, which was the building block to get us to today. And it requires certain things like energy efficient lighting and things like that. So businesses blossomed in the lighting space. But it also promotes doing the implemented ideas that come out of this report. Now with 97, it's happening. So solutions. Started with LED lighting, building enclosure improvements, very big part of this. Improve ventilation, improve controls. That's becoming a very popular thing. PropTech is rising up very rapidly by the way, let me start something. If anybody has any questions along the way, I'm fine with interruptions. I grew up with a sister. So anytime you want to jump in and say something or like, I'm fine to just roll with that.
What is PropTech?
Property technology. So property technology is become a term of art, PropTech, but it really is the metering, monitoring, recording, reporting, managing, two-way street on that. There's a whole world of PropTech that's come about now that Yardi, if you know that word, or any of these kinds of things, there's a lot of people jumping into managing the information. Data is king and AI has stepped in.
Issue of wind turbine here against the built environment that is here in Brooklyn now.
Yeah.
How do you feel about that with solutions that you're
So I think wind turbines are very controversial. And I think we have solutions that don't have to be so controversial. So, different people are bouncing in on different things. There's it's visually and sound and there's birds and there's all this stuff. Does it solve a part of a problem? Yes. Are there other solutions that are much more comfortable to use, less invasive, that are almost invisible? Also, yes. And we'll look at some of those. So I think people just caught a wave, and we're at that early stage of the change in our way in which we deal with the built environment. And all of you, particularly all of you younger people, I not be one of them, is in a great position to watch this evolve. But tacking on to things that are that controversial, I look for what's referred to as blue oceans. Oh, there it is. I can tell the difference. Sorry about that. Which is where everybody isn't. And goes, oh, that would be cool. So there's places like that.
they explode?
I'm sorry?
They explode.
Well, there's all kinds of reasons why people are challenging them. Absolutely. Legacy mechanical stuff. So the HVAC and the domestic hot water together in multifamily, and happy to challenge any of these numbers. These are just from reports that happened a year or two ago. But more importantly is the relative impact. 63% of it is from mechanical and hot water in multifam. And in office, it's 40%. These are significant numbers. So it's an opportunity to educate our client base to understand that there's really an opportunity to do something here, and it will have a return on investment effect, particularly if they're long-term users. If they're flippers, usually they're not interested in any of this. This is a typical building stock. What you find is in the middle of winter, the upper portions of the building have windows and they're all open. That's because the stack effect heats the building. And you have boilers in the bottom and the heat rises up, the air circulates, and you wind up with open windows. And increased cost because now you have to pump more heat into the building. It's really an upside down program, which now we have technology to solve. Comfort, maintenance, managing data. It's hard to calculate how much gas is producing, how many BTUs at any particular point in the day on the south side versus the north side. That now exists with heat pumps and electric technology. So you have all this conventional stuff. One of the biggest things about the conventional stuff on the top line is you need very often 24/7 engineers at the building to maintain this stuff. It's very expensive. It's six-figure stuff. And the reporting is constant. And if you miss reporting, it's expensive. So this technology is kind of done. Then it's when do we start to educate the community? And that's really why I'm doing this. It's all about education and helping us as architects to lead the way, because I think architects have the greatest spot in leading the way in this program. And then you see the other stuff, fan coils, through wall ACs, PTACs, all that stuff, clanking things. So it's moving on to cold source heat pumps. This is the world. And if you look at that, you see that like what's going on is that somewhere where we live hasn't caught on to the program. But the rest of the planet said, this is a good idea. And there are places in the world that don't have fuel anymore. They have sustainable solutions. We're behind because of politics, because of the energy people that want to make sure that their oil and their gas and so on continue to be used. And we have somebody standing up, drill, baby, drill. And that will keep that number down as low as it is. But it's not efficient, it's not good for our health, and it's not good for our environment. Heat pumps. Just give me a quick, because I don't want to spend too much time on this, but do you guys understand what heat pumps do? Exchange heat, move heat from one place to another place. That's all it really is. It's moving in the ACs when you want to cool your space, hot outside, you want it cool inside. All you're doing is exchanging heat in one place and putting it in the other place. Sometimes from the outside in or from the inside out. But it's very inexpensive to make this happen. It's just an evaporator and a compressor and some electric. So from the standpoint of what it costs to do fuel, forget about carbon and all that, this is financially a good idea. And they last. So that's the heating system, same configuration. All of that doesn't change. It just reverses the flow. There are over 20 companies, and these are brands that you all recognize, doing this stuff. They all have different levels of what they do, small scale, large scale, really efficient, really cheap, long-term guarantees, short-term guarantees. That's what we focus on in the company I'm with, is what are the right mixes? And it's something that all of you should get familiar with, because there's a lot behind all of this. And it's a really good thing to learn about, because when I was practicing back in the 90s and 2000s, well, 90s and 80s actually, it was architect first, mechanical, burying the wall. Now it's architect, mechanical, showing up on the same day, figuring out how do we incorporate all this stuff together to have clean, efficient, healthy environments so people will live in whatever we're building. So it's changed. And so this becomes part of our education that we got to pay attention to. So heat pump advantages, real quick, is it's a single mechanical system for your AC, for your heating, and also for your domestic hot water. So now it does all three. So you completely strip out your boiler and your chiller and all the equipment and piping that went with it. So it's a tremendous opportunity, and NYSERDA and Con Ed and all those people are providing funding at different levels, and that's a whole cottage industry that has now grown up to do just that. It's carbon-free on site. It doesn't mean that there isn't somebody making carbon. Electric takes carbon, but it's much more efficient to make it in a box than to make it in 1,000 boxes, managed by 1,000 different people. It's completely modulating. So your south side and your north side can actually be modulated to deal with the loads that represents, which makes your building immediately a lot more efficient. This is older information, so it's not so much attached to the numbers, but in terms of delivered heat, you kind of get a range of what's going on in the world of this stuff. You'll find that the numbers are going to be changing. They're always changing, and there are techniques to manage that. There are auctions and reverse auctions is a whole world unto itself that's grown up. But relatively speaking, you could see why heating and cooling with heat pumps is efficient. It's also very scalable. So there are mini splits, light commercial, large buildings, and mixed loads where you could do heating and cooling at the same time. The mini split world looks like that. It's good for single family homes if you're building a house. This stuff is very familiar to everybody. It's been around a long time. Fujitsu is one of the major manufacturers of it. They make a great product. And if your clients are okay with those on the wall, God bless. That's a great solution. It's very efficient. These, similar, but it gets a light commercial. So you could have one unit like that as opposed to the other one was pretty much 1-for-1 inside and out. This is 1-for-4, and it can go to 5 tons. So you start to expand. You could then do arrays of these things and put them on dunnage, on a roof, or on backyard, or wherever it is. And these things start to, there's a 16-ton array. So you got to get a sense of it. But they look like it's supposed to be there in terms of the technology that we're now starting to work with. And all that's heat pumps. When you work with a manufacturer, what you get is something that looks like that. They, the manufacturer, even though you have an engineer and you have all your teams together, your manufacturer is going to put together one of these. And they spec all the equipment with you. So there's a lot of stuff that's happened to help us to do what we're doing. This is what I was saying about VRF heat recovery. Heat recovery gives you the ability out of one set of machines to do heating and cooling simultaneously, which is a very cool thing. It's expensive, and I'm not going to get into numbers here, but this kind of system creates an ability to keep your south side cool in the middle of the winter while your north side is freezing. And you could do that, and it could be managed from a building wide to an individual room and apartment. And then you can kind of see how this kind of gets played. These things could be scaled pretty much at any scale. When you get to this scale of stuff, you can go 1,000 feet of piping. So you have a lot of room to play in terms of where the piping goes to deliver to the inside units. These are the smaller ones. You get a lot of this these days. We just got a job. I think it's 400 some odd units, and they'll have balconies. So they want to do that. Really simple. It's less expensive, less invasive. Hybrid systems are starting to peel into the space because not everybody can digest the idea that they're going to throw everything away and start anew. So there are hybrid systems, and Trane is one of the companies that's doing that, that is basically keeping a boiler system and putting in a heat pump system. So in the heat pump system, people think they don't work below 10 degrees. They do. They work to minus 10 degrees. The difference is, just so you understand, it's not that they don't heat. They get less efficient and they cost more to run. You're working harder, but they still work. You'll still get heat. But the mentality, the perception is they won't work. So this hybrid idea came up. They have a system that will automatically kick in the boiler below a certain temperature. And people go, oh, that's good. I like that. You don't get as many incentives because now you're keeping your gas lines and your boiler. So there's a give and take in that.
How does the cost change? In terms of how much it costs to heat what you're doing versus the strictly the heat pump without fuel?
If it's just a heat pump and the heat pump is now working harder because now it's 0 degrees out.
Right.
I can't give you an exact figure, but in a particular location I could with a particular job.
Right.
Because it's a calculation, it's an engineering exercise.
Yeah.
But it's just numbers. Right. And they could see what the machine is now going to have to do to be able to make that work. So you could put that into a pro forma.
And when you talk about incentives, you mean tax credits and
Yeah, tax credits. Con Ed does different things. I mean, the cottage industry of funding is a world unto itself. And what I'm planning on doing, just so you know, is, and Sarah and I have talked about this, that to create a kind of series. This is a pretty big, broad overview, and I'm gonna, this is like a fire hose. But what I'm doing now is going to 25. We're going to arrange 4 or 6 of these kind of events, working with ASHRAE and the architects to bring the teams together and put these things together with specific focus. So it's not this big dump of overview as much as it will be, and very open to, like, if you want to reach out to Sarah or to me, my cards are over there. It would be really interesting if we were able to learn deeper about such and such. Because over the next 2 months, we're going to be designing these seminars and putting together a program, whether it's panel discussions, and we'll bring in experts in different things. So the financing could be a panel discussion. What's going on? Yeah.
We're doing a project that incorporates the type of paneling.
Okay.
We're putting the paneling on the outside of the building.
Right.
It's not expensive, but it does cost.
Yeah, I mean, it's a different model. If someone says, if I want to replace my boiler, or I want to put in a heat pump, what's less expensive? A boiler. And the boilers are better now. They have high efficiency boilers, they have dual fuel boilers, they have all kinds of good stuff. But it's good stuff and keeps the 9% rolling in our country. And I think it's our responsibility for ourselves and for our kids to recognize that it's time to change. And like I say, I'm really a proponent. I'm an architect, but I'm a really believer that we see the world holistically. It's a different view, and it's what's needed right now. So this is what indoor units look like. I'll show you some examples of installations, but it's everything from ceiling cassettes, hidden and not hidden, to floor cassettes and wall units. They could be hung in a ceiling, they could be mounted on a wall, they could be hung over a door. This is just an idea. Manhattan College dormitories. That pipe, I don't have a pointer, but the pipe on the right runs through 4 floors. And that's how everything is distributed. It just goes right over the door, and they all are the same. And we just blew that thing out. I think we did it in 8 weeks for the whole dorm. So there's a lot of efficiencies to also installations. This was a church. We do a lot of churches because that's like, I'm a restoration architect from my beginnings, so I really like the idea of bringing things back to life. So they had radiators. We took out the radiators, put in the heat pump, put the panel back on the thing. The vent was there, and now it's a heat pump system. It's cool. There's a lot of creative things, and that's why architects are so important in this equation, because a mechanical guy would have stuck this on the wall. He's not thinking about that. But if we also think about mechanical, now we could be the orchestrators. Hotels, perfect for this kind of stuff. You pop it up there, you duct it up to the front. It looks exactly what it is now, except that's silent, efficient, and it's a heat pump. This is what's called an Epica. It's an Italian company. They're leading the charge in terms of kind of the better looking product in heat pumps. And this is what's referred to as an IOU, an AIO, all in one. So this is everything. There's no outdoor unit, there's nothing. All there is 2 8-inch holes on the outside. And the challenge of this particular unit was, what do you do with the condensate water? Because legally you can't just dump it out to the outside, and if it's doing heating, that water could freeze and now you have a problem. And Sarah knows we did some of these. We pumped it up above a window and sent it out onto an awning which had its own drain, which was pretty much okay. Reality is you need a domestic waste, but everything is real. But this now comes with what they call an evaporator. So underneath, matching that metal cabinet, which is 6 inches deep, is an evaporator. So the condensate water drips down, it goes into the evaporator goes on. It's a toaster oven. It costs money to run it. But when there is water, it will turn it into a mist and shoot it out a hole in the back. And now you don't have a water problem to connect to a drain. Huge difference. I'm installing the first ones in like 2 weeks. People are going to just roll with this and it's going to get perfected. Yes.
Does it have a pump in it, the pump?
It's all gravity. It's gravity. The drain.
But you can install a pump.
If you want to run into
Yes, you 100%. The pump is called a Little Giant, which is kind of cute. And it is a very efficient pump for this kind of thing. And it runs the water to wherever you got to go.
but it's in the unit, or you
No, you buy it
have
separate.
to buy a separate?
And so when you do that, the idea would be to build a cabin around it because you don't want to see the pump. And so it's a thing. It's not just throw the mechanical up in the ceiling. There it is. You don't even know it's there. But it doesn't work like that anymore.
I think Tiny Giant.
Well, I think that's a great idea, but well, it could be a mini giant.
Tiny Giant.
Does that do heating and cooling?
Yes. They're very
So
efficient.
it's replacing a window unit, basically.
It's replacing, if you have a PTAC
Yeah.
with a 40-inch by 19-inch hole, this unit only has two 8-inch holes. So what happens is it gets completely insulated. So all that air infiltration is gone. The two holes are all that's now going to the grill that's already outside. That's it. And then you're done. Yes.
I'll just say,
that the condition that we had, that I had where I used it was the window didn't have room for a PTAC unit. The building had PTAC units except for this one window, which was about 8 inches above an awning. So I had a sliver of a vent that we transitioned from the 8-inch diameter intake and outtake to a long linear grill and installed a pump to get it up. But that was the only reason for the pump.
So if you do that, you need to talk to Sarah because Sarah is also not just an architect, but she can sculpt. And we sculpted the grill to come up and around and fit. Yes. I'm sorry? Yes. This particular unit has a fresh air intake, which is conditioned air ERV. And so that 6-inch unit off the wall is now 12 inches off the wall because the ERV sits right behind it. It fits into the cabinet. It all looks like one thing. But now you have a 12-inch piece and the ERV is fresh air intake. Yes. Well, refrigerant is, everybody knows about, the different refrigerants and all of that. We'll get to that. Yeah. So this is no refrigerant and it's a heat pump. This is a water system. So this is a system, I didn't put the name of it because I'm not trying to get things to happen from that standpoint. But this is one of these this Italian manufacturer. And what you have is that, an air conditioner in the window and a radiator that's got steam or water in it and a boiler downstairs. And instead of that, you get that. And what's in the middle is an array of heat pumps, but they're water source heat pumps. What they are doing is they are producing 70-degree water into a 2-pipe system. So if you're renovating a building that has a 2-pipe system, this could be a very good solution. There's logistic issues to be able to do that, but that said, I keep missing this. Weird. What that's doing is it's creating, as a heat pump, like I showed you in the diagram, 70-degree water. It goes into a 2-pipe system. That 2-pipe system is feeding into that unit over there. That unit over there then either heats the water up to 80 or 85 degrees or cools it down. And you get air conditioning and heating at a very, very inexpensive change in the delta of that water. And now you have no chemicals running through your building. All you have is a water system. And that same unit right there can also be fed into a boiler that will provide domestic hot water. So this does all three.
You can't just put it in a place that doesn't have a water line.
You have to create one. It's a water loop.
You'd have to put it in.
You have to put it into a two-pipe system.
So you're talking about a typical steam pipe system where you have a two-pipe
Yeah,
system.
A
So-
typical steam. There are challenges. I'm not watching the clock up. Somebody's watching. How am I doing?
You're great. You're great, Howard.
Yeah, you want to ask a question?
Yeah, I was gonna ask, thing on the room size, how does it work? Imagine there's a room limit to how much one.
Yeah, so they're pretty much, very often, a unit is a ton. Just to give you a frame of reference, 400 square feet, 500 square feet, plus or minus, depending on ceiling heights and all the things that go with that. So it's a zone. I've got an apartment where we're putting two of them side by side under the windows. I've had three in a living room. So yes, it is sized. You do want to have an engineer size the loads. So all of that is true. And like any other mechanical system, it has to be designed to meet the demand. I'm not going to go through this much, but there is, oh, I'm sorry, yes. That one? It's proving not to be necessary because it's a closed loop system. So even the condensate is looped into the system. So it's not like a chiller, which is pouring that water out. And that's, I'm not going to say pronounce it right, salmonella. Is that right? I did say that. Close. I was close. Legionnaires, thank you. It's better. But anyway, so that doesn't seem to be on the list of concerns. As far as freezing, that's not an issue because as a heat pump, it's constantly moving. Sorry? Oh, 100%. These systems run 24/7. I have two heat pumps in my apartment that run 24/7, but my cost went from 180 to 120, 130. Year round 724. So they are efficient. I mean, that is just what it is. There is a boiler system as well in a heat pump world. I'm not going to get into the details of that, but it's just to let you know that all of this technology is in place, exists, and can be purchased. Value engineering. So I did these all S7s, and if anybody wants the deck, they could have the deck. I'm not making this proprietary thing or anything. So if this is helpful, I'll get it to you and you could share it. And if there's comments or questions or stuff like that, I'm open to whatever you want to do with it. But you first got to get a building assessment. You want an engineering and architectural design. I should have said it the other way, but it really is a combination of the two. And you really need to get both the architect and engineer in the room at the same time to be able to really think through, what are we doing here? What are our options? There's a plethora of options in this engineering space. Got to consider landmarks, you got to sound, aesthetics, all of that. All the stuff that we care about. The engineers just want to get it done. And there are engineers that really get this message. And that's why I'm setting up this thing with ASHRAE. Because the people that I'm talking to are absolutely on the page of collaborating and making this a team. Considerations. These also have ducted systems. If you have ducted systems, you want to make sure that the maintenance is there for the ceiling and all of that, just like any other ducted system. That's not different. You're still blowing air through a space. So that's a consideration if you go in that direction. One of the biggest things that we're starting with in our conversations, we get, oh, can you put in a heat pump? I say, what's your envelope look like? We don't care. Okay, you're wasting a lot of money. But most people are starting to care. And that's again where architecture comes in first, to figure out, what do we do here? Do we reclad? Do we insulate? There's a lot of things that can be done that aren't necessarily very expensive, but between Con Ed and NYSERDA and all these different companies that are out there, there's a capital stack of resources when you dress things that way. That actually helps. Metering, I said that before, the prop tech or property management systems is a big deal. It really helps the model. Refrigerant piping, you asked about refrigerant piping. They keep upping the game in terms of the quality of the material that they're using in these things. The one point of this that's important to see is that inside of 7 inches and 2 inches off the ceiling, you could pipe a whole building. So in that regard, and then this will go to whatever your indoor unit is from wherever your outdoor unit was. And you could heat and air condition a building in any one of those systems. Electrical is always a big deal because buildings weren't necessarily set up. Very often you see apartments with 60 amps. You're lucky if you get 100 amps. But that said, I was at a, do you guys all know the accelerator? So the accelerator is a resource for finding how do you put funding together, and they help you identify contractors, funding resources, systems. Great organization. They ran a thing for the first time, which was for vendors, so that owners, architects, engineers, and all could spend the day at Fordham University and learn about a whole bunch of stuff. One of the things I learned today, which was really shocking, so it's fresh off the page, is that there's a company now that recently got approved to deliver energy, electricity, through wire that we used to deliver music through our speakers. Low voltage wiring. That's approved by the fire department and approved by all the people that do that, which changes the game of all the cost of rewiring a building. So I'm learning about it. I have one brochure here if you're interested in learning about that. But it was really like, that's a game changer. And that's what's happening. There's so many new things coming up very rapidly now. Yes?
You have a sample of that wiring?
I just saw a brochure of it. I mean, I have no idea.
Sounds exciting.
But it's really crazy. But yeah. And that's what it looks like. There's a picture of it, so you can see it. But and it's just a trifold. I mean,
Well, you
jury's
don't-
out.
You don't need your speaker wire anymore, so you're repurposing that. All good.
But it's just an example of how rapidly the environment we're in is changing and how important it is. And I appreciate that you guys came to do this, and that Sarah gave me the opportunity, because we need to get ourselves up to speed on this stuff. It really is a game changer for your practices and for our environment. Ventilation is another one. So in my seminars coming forward, I'm going to bring ventilation people, just like I'm going to bring envelope people, who are very specifically focused on what ventilation does. It's a game changer. I'm looking at a building at 150 West End Avenue, all the Lincoln Towers. We were getting the job. We brought the ventilation guy. The ventilation guy explained to them what they need to do. He's starting first. He's going to get the whole place balanced. And then we're going to do heating and air conditioning. So it really is a very big deal to understand. And he'll be at one of the next events, because there's a number of people also, you all know Howard Zimmerman. He's into this whole thing. And he'll also be one of the people that will be speaking in these kinds of things, so that getting our heads around not just what Zimmerman is known for, which is envelope, but also he's very deep into ventilation. So this is all that stuff, and how you deal with all of that. Where you locate the outdoor units, We're all sensitive to that. I don't have to tell you guys about that. That's what I was showing you in terms of a simulator. It gets pretty deep, but you purchase off of this thing. This that then becomes your spec book, and then you buy out the machines. This is the simplicity of it. So you have your distribution boxes, those horizontal looking boxes here, and then they're fed by your mechanical space back there. So the dash line gets you to the distribution guys, and then the distribution guys send their lines. This is no ductwork. There's no ductwork on those red lines. These are just the lines to the indoor units, and those are all ceiling units all around, which you saw in one of the other slides. So
Those, those represent refrigerant lines, correct?
yes, these are all,
Well,
yes.
I thought there was a limit to how long they could be, that if you went.
Depends on your supply.
Mhm.
So for the larger units, you can go over 1,000 feet.
1,000.
Yeah, so you're not going to have a problem with the building. So that's one of the considerations you have to look at in terms of which system will meet the demands of this particular building. Here's an example of a job that was done like that. And we utilized the decks in the roof. We distributed to the boxes that I just showed you in a plan. Now it's in a section. Those then went to all the indoor units within the space, and that's the building that was done.
The previous design, the outdoor units were in a room.
Yes.
It had a
So
louver or something like that.
So the outdoor of that, like any mechanical space in a building, you see those louvers on the whole side of that facade. It's like that. As long as you can get fresh air to it, you can stick it inside. The controls, use your imagination, is everything you can think of in terms of how you control it, including your phone. So everything is now in that wireless world that you could manage your systems. Even that little Apaca thing in somebody's apartment, you could hook it up to your iPhone, and coming back from the airport, you could turn on your heat. So systems are much more efficient that way. I'm just going to start to close. One of the big challenges that started out, I don't know if it's still out there in the market, but it was the grid's not going to be able to handle this. And if you're electrifying everything, we're going to blow up the world. And there's two reasons why that's not true. This is Urban Green, if you know Urban Green. But they're really one of the really top organizations bringing this kind of conversation to the table. But our grid was built for air conditioning. It's very robust. Heat pumps use significantly 50, 60, 70% less energy to do a heat pump than a window air conditioner. On the heating side, nobody paid for it because it was gas or oil. That's where the balance comes in. The grid is the same grid. Now you're going to do that same grid. There I am. Sorry. I have Italian in me too. But the grid is now built for the cooling season. Well, for the heating season, it's not going to be any more than that. So, and the heat pump doesn't care if it's hot or cold outside. All it's doing is flipping the way the air is moving. So it's very efficient in both sides. Just a quick look at other things going on. So heat pumps, we talked about air source, water source, all-in-one systems. There's hybrid systems, all of that. Solar arrays, wind technologies, which we're going to erase. Thank you very much. But battery storage systems are coming up the curve very rapidly because balancing when electricity is expensive versus when it's cheap at night. Well, if you could store the stuff on the battery, so on the day it's eating the battery and at night it's drawing the electric, significant savings. And now battery systems, which started out as a problem for the fire department because blowing up and all the stuff that's happening, now they're battery systems that are accepted. And now you're going to start to see this more and more. And they're perfect for a heat pump because that's all it uses. Geothermal is coming up the curve. I don't know if you're aware that St. Patrick's Cathedral was done with geothermal, but they had a ridiculous amount of money. And now they have free energy for the rest of eternity. But they are getting simpler, less deep, and they have heat pump concept, if you will. They're taking a temperature from the ground and raising it and lowering it for very little cost and distributing it. So that's coming up the curve pretty rapidly now too. And I know developers that are testing these things. Solar building panel and solar glass. That's another one that's coming up the curve. Again, very rapidly. I'm only in this business 3 years. When I saw it 3 years ago, I was talking to people who are doing solar glass, and they said, everybody wants it, but nobody will be the first one. Well, now the first one has happened, and people are going to start to see it. And the incentives for solar glass make it less expensive than regular glass. So all of a sudden, when people find that out, as you just did, you'll start, well, if I'm going to put in a new window, maybe I can get a deal on that. And then it becomes like, well, they're making electricity out of that. Well, feeds the heat pump. Well, that's pretty cool. Big buildings will start to look at that. That south-facing facade is going to become a battery, which is really kind of neat. So, in summary, I did get summary. How did I do?
Great.
Still okay. Okay,
Good.
good. Sorry, I have no idea about time. So we know about the local laws, what heat pumps are doing, and everything I just summarized. I just said before, and then tax incentives, credits, utility rebates, loan programs. It's all out there. It's an industry that is helping us do this so that our clients go, but I can't afford it. They don't understand it, is really what's going on. And that's the job we got, is to be able to inform. Yeah, sorry. No, they don't. They actually don't. They're quite silent. I have on my phone, and you might want to get it, but it's a dB meter. I use it in restaurants now, and I walk in, and if it's hitting a certain number, but but they are very
You're
quiet.
saying if the air conditioning equipment hits a certain number, you walk out.
I'm saying this, yes, that too. I'm with you on that. Yes,
What about this? What about this particular building we're in? What system could you
this
use?
is traditional stuff.
This is traditional.
That's what it looks like. I mean, yeah, it's just a ducted system. Yeah.
If you were given the opportunity to redesign the ventilation, the heating system for this building, which one of those methodologies would you use?
In a building like this with open ceilings, pretty much, and I'm only looking at this floor, I would go with, if you remember from earlier, I could go find it, an exposed ceiling mounted unit. And I would find the space where the mechanical systems are up on the roof or in a mechanical room on each floor. Sometimes that's what happens in buildings like this. They have a sleeve where it's all mechanicals up and down the side of a building. And I would capture that fresh air. I put my heat pump in there. I get rid of all of this ductwork or leave it in place. And I would just put my units in. And then I'd be able to condition and zone this thing and manage those zones very efficiently. And if this is the only part of the building that's occupied, it will be the only part of the building that's on. And the whole rest of the building, air conditioning or heating, will be turned off. You can't do that with these systems. There are buildings that you're going to have 24 hours of use because your team is on. You got to buy the system for the whole building. Very expensive. We're getting rid of that.
I just want to say thank you for providing a very basic but technical presentation about this technology. I actually just installed an air source heat pump in my home, and my house is solarized, so it's actually carbon free. To your earlier comment,
Great.
something that's really compelling to me is you brought up this question about this is really only viable because there are incentives and credits and rebates like right now, right? And you're making this case that there needs to be some financial expertise embedded in the work that we're doing. And I'm just wondering what your thoughts are about who's holding that expertise, especially when it crosswalks to things that are perhaps targeted towards populations that don't have like the competency or the capacity or really the resources to pursue compliance for things like the IRA, right? Does that question make sense?
Yeah, I guess you all heard that it's really the only way that this technology is being born is because there are incentives, and the answer is substantially yes. Right now, incentives are what's propelling. If you think of it as a J curve, we're in the early stages of that. So in order to launch it, you need to get support from the government to be able to do that, or from the financial institutions to support that. So there's PACE financing as an example, which is not government, okay, it's private funding. And PACE financing is built on the idea that if a building will assign the savings to the loan company, the PACE funder, for what looks like a mortgage, 20 or 30 years, so it's de minimis in the monthly going forward, they will fund the whole thing, no cost, and you're committed. The key to it is it PACE, that funding steps in front of any other loan that you may have. So it didn't get off the ground as quickly as they had hoped, but now that's being navigated. So and that's without any public funding.
Mhm.
That just gives you an ability to manage the cost in a mortgage style fashion.
So what I'm actually saying, the question I have, right, is like you're coming at this from both an architect and a developer background, and I'm an architect and I've been in development also,
Great,
right? And you have this expertise about how to do this financially, but most people don't.
right.
And when you talk about like architects having holistic view around how to implement this, it assumes that the architect has to have a certain capacity in the financing aspect that frankly most architects don't have.
Okay, so let me address that very specifically, because coming out of architecture and going into development and learning the financial modeling and all that craziness that goes with that, what I think architects have as a particular skill set, or their superpower, if you will, is team assembly. That's what architects do. They understand how to recognize talent, how to recognize resources, whether it's the carpet or the engineer. And whatever they do, what they're really good at is putting together the right team that meets the need of that client. That financing piece is no different from any of the other members of the team. You, as the architect, don't need to understand, unless you want to play, the whole capital stack. Know the language of capital stack. That's a good idea. But then go get the capital stack person that really gets that and add them to your team early on, so that you are equipped to then select what makes sense, so you could be intelligent to your client. You're the presenter, not the financial guy. In the end of the day, that's why I say it's a holistic view, but we're team assemblers. That's what we do. Developers are team assemblers.
Hi. So, in terms of technology, or even very simply installation, do we have to face several differences with what we do now? Because, for personal experience, I know that trades are not very open to this kind of changes sometimes. So, I can already hear the plumbers and the electricians yell at me for proposing stuff like that.
That's great that you brought that up. So I feel like a politician. Thank you for that question.
Please.
I don't want.
It's something I face every day.
Terrible.
So
But that was a good. No, that's a really important thing. So let me just give you the state of the art as I understand it right now in that space, because people that do tin knocking and do that kind of stuff are not the same guys that are going to do brazing. And brazing is a different technology, and it's a certain skill set that needs to be taught, learned, and expanded upon. And this technology requires brazing. So there's a few things going on right now which are kind of really interesting, and I'm somewhat involved in that as well. So if you've heard of Apex Schools, it was a trade school, private trade school around the country. A nonprofit called FedCat bought them, turned them into a nonprofit trade school, and they are building a network of schools. Interestingly enough, starting in Houston, but they're building a network of schools, ultimately around the country, to meet that need and training people. City College, I was with them today because I invited them to be part of this seminar conversation to address that specific question. They are building trade seminars to do this. So we're at the early stage, which makes it completely exciting, open, and a huge opportunity if you want to play in this space and still do your architecture, but you get to raise the bar because of all the benefits that come out of this, from ROI to healthy buildings to branding. I mean, all of that is a communication to the long-term player. I always speak about the long-term player because the short-term players have a different mission. They just want to make quick bucks and move. This is for our future. And that's why this makes sense. Yes.
Yeah, so just to point out, you don't need tax incentives and funding to implement what Howard's talking about.
No.
It's happening already. It's been happening. I'm an architect. I also do a little bit of developing on the side. And all my new residential properties were using VRFs and heat pumps, hybrid heat, to do heating and cooling. And I'm not getting any incentives from anyone. Con Ed offers incentives. I actually tried. I gave up. You have to use their contractors. You have to go by their standards. It would have delayed my project for about 4 months. And at the end of the day, they only would have picked up a minuscule cost of the job. So you have to do your own homework, but it's our job to educate our clients what Howard is telling us. So it's not our job to tell the clients how to get the funding. It's our job to educate them on what's available. This is successful because it's small, it's practical, it's efficient, and it works. One thing to add to that, kind of contrary to that, I have a few apartments. My new apartments all have VRF systems. My old apartments have gas-fired furnaces. February, March, April, May comes, all my tenants that have the VRFs complain about their electric bills. None of my tenants that have gas complain about their bills. But it's going to get cheaper and cheaper as time goes on. Thanks, Howard.
And there's also, I appreciate that, because that is very much spot on. A lot of people say, forget the incentives. It's just too much to deal with. And you don't need it necessarily because the return on investment just gets extended a little bit. That's really what the net result will be, because there is a savings in the end of the day. And I'll talk to you later about, the gas is cheaper. But with a heat pump, the electric is cheaper. And that depends on the system you use and so on. But we could talk about that offline.
If you're working on a larger project like Giuseppe does, versus a project where you're
Right there.
renovating your own house and you don't have the funds, it's critical to understand where you can get financing.
Yeah. And also there's credits
If
for
you're working on a single family home versus like a multi-family, where the scale of the size of the project makes it financing much different. Pro forma of how much money you're investing in it, and how long it's going to take for you to actually get a return on your investment.
Yeah, it's definitely comes into time.
Yeah.
And also what your time frame is. If you're going to live in a house for 30 years and you're going to be putting something like that in to the house, even if it costs you a little more, it's healthier, it's cleaner, it's more efficient, and it's quieter. Yeah. And you're not worried about the fuel markets. So there's a lot that goes into this conversation, but that's, I think, our job is to know about it and share it with the client base that we happen to be dealing with.
I think we have time for just one more question, and then we'll do some closing remarks.
Hello, wonderful presentation.
Thank you.
I work with an energy company in Houston that is using technology from NASA spacecraft for here on Earth. And make a long story short, we can produce 10 times the electricity at current generation solar for 2 or 3 cents a kilowatt. And of course, the objective would be to make every building not only an energy user, but an energy producer and sell it into the grid, which of course has wonderful benefits for developers, the owners of the buildings, if they not only provide their own concerns, but also can provide it for the rest of the community, and also prevent energy disasters like what happened in New York in August of 2003, if you might remember. The centralized system has a major flaw that way. So the question is, how can one combine, potentially combine, this is an open-ended question, a energy capture in each building with your system of heat pumps, to.
That's another one that came up today, and it was really interesting that there is another cottage industry. There's a lot of cottage industries. It's a very cool thing. That's what's so exciting about the times we're in. You can ignore the noise, but in that regard, there's a cottage industry that's growing up, which is called a virtual energy bank. And that virtual energy bank, by definition, is the energy you're talking about. When you're shaving that back, where does it go? Well, there's now creative people saying, what goes into a bank? Now it could be resold at a much less cost because it was next to free. So that's starting to happen on micro levels around, which is a really interesting source of energy when people are paying attention this way. But we're not going to get that to happen if we're using fossil fuels, because there's no energy bank to create. But if you're using electricity and you could shave things down at night and use them from batteries during the day, well, all of a sudden you end up with extra energy. Where does it go? Now you have a bank. It could be sold. And you think about that. The thing that was, I always use this as an example. The thing that was bothering me before, when I came into this world, didn't exist. When I went into the architecture space, I was amazed that there was this kind of flip thing that had a black and white screen that you could dial and get somebody on the phone that you're running late. And then it got color. And I was like, whoa, they could colorize these things. And then it became a Cray computer. And then it went beyond the Cray computer. It incorporated AI. You could ask it anything. The built environment is very, very slow to adapt to technology. And we have BIM and we have all this kind of stuff. But it's very, very slow. And we have the opportunity to accelerate it by having these kinds of conversations and letting people know that this stuff is out there, it exists, it's usable. And that's why I'm committing to doing these conversations, because I think that we all win if we do that and now inform each other and ask the questions. I thank you all for asking questions. The worst thing happens when you do these kind of things that people go, well, that was kind of interesting. So thanks a lot for that.
Thank you. Thank you, Howard. Well, there's another person in this room, Joe Harris from Crescendo Designs, that talks a lot of overlapping technologies. A lot of the things that Howard is talking about, giving back to the grid. Joe is dealing with battery systems that are working with the electrification of your home on how to use energy at its lowest cost if you are buying from the grid, how to store it and use it on your own and manage it. Things that aren't allowed in New York, batteries aren't allowed in New York City as of yet, but I suspect that it will be possible to do in the next 10 years or so. So we're going to keep you informed by more of these presentations that are devoted to this. If you have an interest in any of the things I'm talking about, please email me at president@aiabrooklyn.org, and I will link you to the presentation, AKA the deck, that Howard provided for us, and I can send you a copy of that. And we'll just keep you informed with the programs going forward. And I have a few more questions for you, Howard. Now, we're going to do that, take this to eat up and drink the rest of the things that are here. We have some time to speak with each other, to mingle, and to keep talking. I'd say for another 20 minutes or so. We do need to be fully out of here by 8:30, but so think about 10 quarter after as your time, and we'll clean up after that. Thank you, everybody.
you.